Welcome to the Explainer. Okay, today we're taking a seriously fascinating bottom-up journey into the hidden architecture of modern web apps. If you've ever wondered how a simple click transforms into a beautifully complex, data-rich web page, you are exactly in the right place. We're going to deconstruct the technology stack step by step, starting from the raw data and working our way all the way up to the polished user interface. To help us out, think of our web application as a busy, high-end restaurant, where we'll go from the pantry all the way to the manager's desk.
Here is our roadmap for today. We're going to cover data operations, REST APIs, dynamic pages with JSP, managing data with Java Beans, reusable templates, and finally wrap it up with the ultimate admin dashboard.
All right, part one, data operations, CRUD, and SQL.
Let's step right into our digital pantry. Now, at the very heart of all data management is CRUD. Yeah, C-R-U-D. It stands for create, read, update, and delete. And honestly, it really doesn't matter if you're looking at a massive global social media platform or just a simple digital to-do list, CRUD is the absolute fundamental way any application manipulates and manages its stored data. So you might be wondering, how do these four simple concepts actually talk to a database? Well, they directly translate into specific SQL queries. When our app wants to create a new user account, it sends an insert query. Need to read a profile? It uses select. To update an email address, naturally, it uses update. And to delete an account, you guessed it, the delete query. It's just a perfect one-to-one mapping. Moving right along to part two, communicating with REST APIs. Okay, let's step out of the pantry. We're now meeting the waiter of our restaurant analogy, the REST API. REST stands for Representational State Transfer. In plain terms, it's the workflow bridge for the web. It's the standard way for a client, like the web browser you're using right now, to send HTTP requests to a server and then receive HTTP responses back. Literally, without this bridge, our web app is completely isolated, just sitting there. Think about a standard client-server workflow. The client asks the server for data using specific commands: get, post, put, or delete. Notice the pattern? Yep, those are the HTTP equivalents of our CRUD operations. The REST API sits perfectly right in the middle, securely managing this whole exchange and then returning the data neatly formatted as JSON, XML, or HTML. But how does our waiter actually tell us if the kitchen is out of soup? Well, it uses HTTP status codes. When the server responds via the REST API, it attaches a little 3-digit code. The 100s, those are informational, meaning, hey, the request is processing. 200s are the golden ticket, total success. 300s mean redirection. But if you see a 400-level code like the infamous 404, that's a client error. The server literally couldn't find what you asked for. Fun fact for you, there's actually an official 418 status code that literally means I'm a teapot. It's a hilarious inside joke among developers. And those 500s, yeah, that means the server itself had a critical failure. Not good. All right, into part three, dynamic pages with JSP. Now we're introduced to our chefs, Java Server Pages, or JSP for short. These are responsible for taking that raw data and plating it up into a beautiful, dynamic web page. But before our JSP chef can get to work, it needs instructions, right? We call these directives. They tell the JSP engine exactly how to convert the page into a servlet. There's the page directive, which applies global settings like importing Java classes. Then there's the include directive, letting us smoothly drop in other files like a standard HTML contact form. And finally, the taglib directive, which lets developers declare custom tags for some seriously powerful functionality. To really wrap your head around JSP, you've got to understand its lifecycle. It's super organized. It kicks off with initialization, where JSP init is called to set everything up. Then we hit the heavy lifting, the JSP service method. This handles the actual back and forth of the client's requests and the server's responses. And finally, when the servlet is done and no longer needed, it shuts down via JSP destroy. It's a totally predictable, highly organized cycle. Next up, part four, managing data with Java Beans. So if JSP is our chef, Java Beans act as the specialized, perfectly organized prep containers that keep ingredients strictly portioned and ready to go. Now, Java Bean might sound a little intimidating, but honestly, it's just a regular Java class that follows a very strict set of rules. Why so strict? It's so development tools can automatically discover its properties.
The data variables inside have to be kept private. To interact with that data, you absolutely must use public getter and setter methods. Oh, and it has to contain a public constructor with exactly 0 arguments. Strict, but necessary. When you look at the actual code, a classic Java Bean architecture features properties, say a private string name and a private integer age, that are completely locked away. To safely access or change those, the app uses the public getName or setName methods. This kind of encapsulation is absolutely crucial because it keeps the application secure and stops our data from being randomly overwritten by mistake. So here's how it all comes together. Our JSP webpage talks to this bean using action tags. For example, JSP cbean will locate or create the object. Then JSP set property injects a value, like the name Prithavi Maharjan, straight into the bean. Finally, JSP get property pulls that exact value right back out and displays it seamlessly on the HTML page for the user to see. It's this beautiful dance between backend data and front-end presentation. Moving right into part 5, reusable templates and design. All right, now that we know how to fetch and display data, we really need to talk about efficiency. Picture a website with 1,000 pages. Every single one of those pages has the exact same navigation bar and the exact same footer. So the big question is, how on earth do we avoid rewriting the exact same HTML code 1,000 times? Because think about it, if the company updates its logo, you do not want to sit there manually editing 1,000 different files. No way. The secret here is the DRY principle. Don't repeat yourself. By using JSP include tags, developers create modular static templates. You build one header file and one footer file. This gives you a single point of change. You update the header file once and boom, that change is instantly reflected across all 1,000 pages of your app. This literally saves developers hundreds of hours and guarantees your design stays perfectly consistent. But wait, what if that shared header needs to say welcome home on the home page, but welcome to settings on the settings page? Well, you use the JSP param action tag. This little tag is a real game changer. It lets you take a static template and inject dynamic content into it based on exactly which page the user is viewing. So you get the amazing efficiency of a single template, but with the flexibility of custom page-by-page data. Pretty clever, right? And finally, part 6, the ultimate admin dashboard. We have officially arrived at the climax of our application's architecture, the dashboard. Remember our restaurant manager? This is their high-level overview. All of those raw CRUD operations we talked about, the REST API requests, the Java beans holding user info, they all aggregate right here into clear, immediate functions. The dashboard takes thousands of fragmented database rows and magically transforms them into clean, readable metrics like daily sales, user locations, and total visitors. But don't let those simple, beautiful charts fool you. Generating them takes some intense SQL logic running behind the scenes. When a developer is analyzing data, they usually choose between 2 main methods. A join efficiently combines data spread across multiple tables, like, say, linking the sales table with the categories table, using just one single query. A nested query, on the other hand, filters data using a subquery. Now, nested queries are super useful, but they run multiple times and can become incredibly slow. We're talking turning a quick 2-second dashboard load into a painful 5-minute crawl if you're dealing with massive datasets. Ultimately, bringing all this architecture together into a well-managed dashboard delivers massive business value. It drives operational efficiency by streamlining workflows. It seriously improves the user experience since admins can spot and fix issues in a snap. It locks down security and regulatory compliance by keeping data oversight centralized. And maybe most importantly, this whole structured architecture gives the business the scalability it needs for rapid, sustainable growth. Well, we have covered a massive amount of ground today, all the way from the database pantry right up to the executive dashboard. So the next time you log into a completely seamless web app, take just a second to ask yourself, how many REST API calls, encapsulated Java beans, and complex SQL joins are working silently in the background right at that exact moment just to show you your profile? The invisible complexity behind our everyday digital interactions is just absolutely magnificent. Thanks so much for learning with the explainer.